In this video we're going to talk about mutability and equality. So let's have a look at a list, say here. Here's a list, 11, 22, 33, 44. Now lists are mutable, that means we can change them. So we've got the same object L, and then maybe we're going to change the last element. That's going to be so remember, the last element of the list can be referred to as L minus 1, counting from the end. And so let's change that. It was 44. Let's change it to 4444. And then let's see what we've got. So, so we'd had the same list and we changed it. So now it's different. And in fact, we could we can do a kind of let's actually do it this way. So we do L dot append. Minus 9 and n. So the append method there, that also changes the list by sticking some stuff on the end of it. Okay, so as a list are mutable, we can change them. But let's instead do a tuple. Okay, so there's various differences between tuples and lists, which we'll maybe get into as they come up later. But kind of first main difference that we just want to mention here is that tuples are not mutable. If we try and change the end of the tuple here, then we're going to get an error message, type error, tuple object does not support item assignment. We can't assign to an element in the tuple, so that doesn't work. And similarly, there's no, so it's here, got another error message, tuple object has no attribute append, so we can't, there's no append method for tuples, so we can't do that. So lists are mutable, and but tuples are not. Sets, or we can sometimes deal with sets instead of lists. So remember, the difference between a set and a list is, a list is naturally ordered, but a set has no order to it, and and if you've got a list, the same element can appear a bunch of different times, and it matters how many times it appears, whereas in a set that's not true. So let's have a set here. So S is going to be set 5, 6, 7, 8, 9. Okay. And again, so sets are mutable. We can to add an element to the set, we use the add method. So let's add 10 onto our set, and so we've managed to change it. We've managed to change the set there because again, sets are mutable. Strings are not mutable. Okay, so let's string x. So x is going to be A, B, C, D, E, F. So we can do x, and remember, it's possible to sort of we just want the character number 2 in x is we just do x bracket 2. So okay, let's just put a print here. The way these stupid notebooks work, it'll kind of automatically print the last thing that you evaluate. But if you want to print, if you want to see more than just the last thing, you need to put in some print statements. Okay, so here we print x. So you've got A, B, C, D, F, and x2 is that. So let's try and change it, right? So and so x2, let's try and set that to be equal to z instead. Okay, so again, string object does not support item assignment. Strings are not mutable. We can't do this kind of thing. Notice that we can do things like x dot upper, right? That converts x to uppercase. But so in some sense that kind of changes x, but it just kind of, this produces a changed string, but it leaves the original string as it was, right? So we print x dot upper, so we've converted x to uppercase, but that was a kind of new copy of the string converted to uppercase. And if we just print x again, you see the original x is unchanged. So we haven't actually mutated the string x that we started with. Okay. Now this all kind of ties up with another issue, which is kind of about equality. So let's go back to lists, right? So okay, so here we've got two lists, so but they're kind of the same list. So if we test, we ask Python if they're the same. Double equals is the usual way for testing for equality, and it'll tell us that yeah, it's true that they're the same. But they're just kind of, in some sense, accidentally the same. In Python's mind, they're sort of two different things. It's got like it's written the same list on two different pages in a notebook, and we can change one page and not change the other page. Okay, so we can say L1.append 999, and then so we appended we put a 999 on the end of list L1, but L1 and L0, they're kind of not linked. So when I change L1, it doesn't automatically change L0, even though they used to be the same. And also we can sort of check that they're kind of essentially different objects stored in different places by typing L0 is L1, right? Okay, you should kind of think of that as being a question, not a statement. It's a question: is L0 the same as L1? It says false right there. And even if we did it here, kind of, if we did it when we originally defined L0 and L1, but they're separate lists, so even though they're kind of the same, as detected by the double equal operator, they're different as by the is operator, because they're kind of stored in different places in Python's memory. But we could do a different thing. We could do L1 equals L0 here. So we assign L1 to be L0. Now, in this case, L0 and L1 are, if you do an assignment like this, the effect is that L1 and L0 are just two names for the same list in the same place in Python's memory. Okay, so L0 is L1 returns true, and L0 double equal L1 also returns true. And now if I append 999 to L1, then because L1 and L0 are just kind of two names for the same list recorded in the same place, changing L1 actually changes L0 as well. And so this is kind of more or less the same story that you expect with any kind of mutable types. Another thing that we could do. Okay, so let's put in. So now we've got L0 and L1, which are kind of stored in the same place, and L2, which happens to have the same elements but is stored somewhere different. So another thing that we can do id L0 okay. So you see each of these things that has an identity number, which kind of is a sort of number which identifies where it's stored in memory. And if you look at these, the identity numbers for L0 and L1 are actually the same. They just kind of end this 4032 in the serial number. So this is another way of seeing that L0 and L1 are just kind of two different names for the same thing. Whereas L2, the identity number is different. So L2 is pointing to a different place that just happens to have the same contents. So I think that's all we need to say for the minute about mutability and equality.